Okay, so now let's look at this series here. So it is not a familiar series, right? It is an alternating series. So now, since in this case we're interested in absolute convergence, we would consider the series of absolute values. Okay, but also let's look at this too. We've got a factorial in here. So this would be a candidate for the ratio test. So that's what we're going to try. So let's use the ratio test, because the ratio test involves taking the absolute value of this. So that'll basically take care of the alternating series part. So let's do it. So we're going to define rho as equal to the limit as n approaches infinity. And again, I'm going to drop the -1 to the power because we're using absolute values. So the absolute value of this is going to go away. So this is going to end up being the limit as 3n. So I'm going to use the ratio test. So I'm going to have 3 times n plus 1 over n plus 1 quantity factorial divided by 3n plus 1 over n factorial. And so now I'm going to write this as the limit as n approaches infinity. And again, I'm going to multiply by the reciprocal of the bottom. And so this is going to be what? This is going to be 3n plus 4 over n plus 1 quantity factorial times n factorial over 3n plus 1. Now, again, I know that this is going to cancel with this, and it's going to leave me an n plus 1. So again, by the previous videos, I've already gone over that. So this is going to be the limit as n approaches infinity of, now the quantity becomes 3n plus 4 over the quantity n plus 1 times 3n plus 1. Okay, now, look, where's this thing going? Well, I can already tell that this is going to go to 0. But let's go one more step here. This is going to be 3n plus 4, and this is going to end up being 3n squared plus 4n plus 1. Okay, so again, if we divide the top and the bottom by n squared, we're going to get 0 over 3, which equals 0. So this is going to go to 0, okay, which is not equal to 1. Okay? And so therefore the series converges, right? And we can conclude that the original series converges. And so therefore this converges. Have a great day.